previous lecture I explained you about pH chart, TS chart and steam refrigeration table. I explained the pH, TS and refrigeration table in my previous lecture, which is most helpful in understanding vapor compression refrigeration system. The below diagram is this diagram is given as a vapor compression refrigeration system, which is our refrigerator work. I explain you vapor compression refrigeration system, which is the most important again, for which the pH and TS chart is most important. I already explained the pH and TS chart. I explained the pH chart through a graphical representation. I also explained the TS chart. I explained the mathematical utilization of pH and TS chart in vapor compression refrigeration system. Now I am going through the vapor compression refrigeration system. This is the vapor compression refrigeration system, in which there is a compressor. There is a compressor. Second one is a condenser. After this, third one is an expansion valve. Fourth one is evaporator. The four major components which we are using in vapor compression refrigeration system. The number one is vapor compressor. Number two is condenser. Number three is expansion valve. Number four is evaporator. Evaporator is work as a chiller, which we are using to decrease the temperature of the system. So there are four major components which we are using: compressor, condenser, expansion valve and evaporator. From point number 1 to 2, there is a compression, isentropic compression. I want to use the processes which we are using. Wherever there is a compression process through piston cylinder arrangement, there is isentropic. That means entropy is constant. From point 1 to 2, there is isentropic process. Entropy is constant. After this, whenever this heat exchanger, evaporator, it is removed in condenser, there is heat is absorbed in evaporator. That means 2 to 3, there is a constant pressure heat removal. There is a constant pressure heat removal process. After this, QR, heat removal process. After this, 3 to 4, there is an expansion valve. This is the expansion valve. The term used is over here, the expansion valve. In expansion valve, this is the expansion valve. In expansion valve, the process is isoenthalpic. 3 to 4, there is a process isoenthalpic. There is enthalpy constant. This is throttle valve as an expansion valve. Through this, there is isoenthalpic process. Enthalpy is constant between point number 3 and point number 4. After this, there is an evaporator which we are using for absorbing heat from the system. This is 4 to 1. Again a constant pressure process, because heat energy is absorbed from the system at a very low temperature. This is QL means lower, QH means higher. This is QH, this one is QH, this one is QL. That means QH at higher, heat removed at a higher temperature, heat absorbed at a lower temperature. Heat absorbed, this one is a heat absorbed at a lower temperature. This is heat removed at a higher temperature. Let's process 1 to 2. From 1 to 2, there is a compression process. Compression takes place. Process is isentropic. There is an isentropic process takes place, due to isentropic process, there is increase in pressure and there is increase in temperature, both in this case. If the process 1 to 2, there is isentropic process, due to which there is increase in pressure and increase in temperature. From P1 to, there is increase in pressure P2 and the temperature T1 to T2. After this, there is a condensation takes place. Condenser, in condenser, the heat energy is removed at a constant pressure. And we go to the point number 3, which is saturated liquid. At condenser, at a constant pressure, heat energy is removed. At a constant pressure, the heat energy is removed. This is at a higher temperature, heat energy is removed. I explain this condenser is the most important part, because condenser and evaporator, because in condenser, in saturated region, there is constant temperature takes process, but in superheated region, there is decrease in temperature in condenser, in case of condensation. So one more point, at subcooling, there is decrease in temperature, again decrease in temperature in case of condenser. I will explain this through pH chart, easily through pH chart. So from point number 1 to 2, there is a compression at saturated vapor. Most important is saturated vapor. At saturated vapor, after this, point number 2, it is superheated vapor. Point number 2, there is superheated vapor. At point number 3, all the molecules are in form of saturated liquid state. That's mean at point number 3, all the molecules are in liquid state. After this, 3 to 4, process 3 to 4, there is an expansion valve. Expansion process is isoenthalpic. Isoenthalpically expand the liquid at a higher pressure. There is the pressure P. At this point, the pressure is again P2, because condensation takes place at a constant pressure. That's mean here P2 is pressure. That's mean at this point number 3, the pressure is same, P2. We have to follow. That's mean explain. Here the pressure is P2. This is a constant pressure process. That's mean at point number 3, the pressure is P2. After this, there is an expansion process. Expansion takes place, due to which there is huge decrease in pressure and huge decrease in temperature. That's mean at this point we got, at point number 4, we got the pressure P1. At this point we got the pressure P1 and temperature is T4. At this point, heat energy is absorbed from the system. Heat energy, QL is a lower heat energy, lower form. The heat energy is absorbed from the system by the evaporator, and there is continuously increase in heat energy. That's mean at a constant pressure, evaporator is work on constant pressure. At P1 is, here is a P1 pressure, and again here is a P1 pressure. That's mean in whole cycle there is a constant pressure, and isentropic process and isoenthalpic process takes place. That's mean I will explain in this diagram in a better way. That's mean this is isentropic process, this is constant pressure, this is isoenthalpic, this is again constant pressure process. That's mean at this point pressure is P1, at this point pressure is P2. This is constant pressure condenser. That's mean here it is P2. This is isoenthalpic expanding process. At this point pressure is P1. That's mean in the whole cycle there are two pressure, P1 and P2. This is the cycle is working on two pressure lines. There are two pressure lines, P2 and P1. There is one isentropic process and one isoenthalpic process. There is increase in pressure and temperature both due to compression. There is decrease in pressure and temperature both due to expansion. But in the case of condenser, there is a constant pressure. In the case of evaporator, there is a constant pressure. In saturated region, temperature is constant, both case temperature is constant. But in superheated region, T superheated, T saturated. In superheated region, there is decrease in temperature in this case, condenser case. But in this case, evaporator case, there is increase in temperature at superheated. I will explain you through pH chart. But first of all, you have to learn the processes. The vapor, again, the most important is, this is isentropic, this is isoenthalpic, this is constant pressure, this is constant pressure. That's mean there is two constant pressure, one isentropic, one isoenthalpic. In compressor, there is isentropic process, condenser, constant pressure, expansion wall, isoenthalpic, and again this is a constant pressure. After this, there are some term is given: superheated vapors, saturated liquid, saturated liquid plus vapor. That's mean wet region. That's mean at point number 1, saturated vapors are there. At point number 2, superheated vapors are there. At point number 3, saturated liquid. That's mean all the molecules are in liquid form. This is in between wet region, liquid plus vapor. So now I'm moving to my main diagram, PS diagram. This is the PS diagram, pressure and enthalpy. This is the point number 1. Point number 1 is dry saturated vapors. This is saturated vapor. That's mean this is critical point. Through critical vapor line, this is saturated liquid line, saturated liquid, saturated vapor. This is saturated vapor point. From this point, there is a isentropic compression. Point number 1 to 2, isentropic lines are moving like this. This is isentropic line. Check. After this, this is point number 2, 2 to 3. 3 point number is superheated to saturated liquid line. This is saturated liquid. That's mean 2 to saturated liquid. This is saturated liquid line. This is saturated liquid. This is point number 3. Air pressure is P2. Air pressure is P1. That's mean at P1 there is dry saturated vapor. P1 dry saturated vapors. In same diagram, P1 dry saturated. In this case, P1 is dry saturated because it is exists on dry saturated line. After this 1 to 2, at point 2, superheated vapors, isentropically expand, isentropic process. These are isentropic lines. This is point number 2 at pressure P2. This is P2 pressure. That's mean isentropically compression up to point number 2. This is 1 to 2 isentropic compression, 1 to 2 isentropic compression, superheated region. 2 to 3, there is condensation process at a constant pressure up to saturated liquid. 2 to 3, there is a constant pressure. This is a constant pressure line. This is a constant pressure line. Constant pressure line up to saturated liquid line. This is saturated liquid because saturated liquid line. This is a saturated liquid line. Saturated liquid. After this, 3 to 4, there is an isoenthalpic. Enthalpy is constant. Enthalpy a straight line. This is isoenthalpic process. That means H3 is equal to H4. Enthalpy is same at both the points. This is constant enthalpy. Isoenthalpic expansion. After this, 4 to 1 evaporator. At a constant pressure, heat energy is absorbed. This is 4 to 1. There is heat energy absorbed from the system. That liquid portion is converted into is continuously increasing. In this case, at point number 1, all molecules are in dry saturated state. All the molecules are in dry saturated state. This is point number 4. Then this is moving toward this. There is increase in enthalpy, increase in heat energy due to absorption process. Absorbs heat energy from the lower level, lower heat systems. That means the dryness fraction is continuously increasing. That amount of water vapor are continuously increasing due to absorption of it. This is point number 1. This is vapor compression cycle. I again explain this one with my basic diagram. This is a PS diagram. This is PS diagram for R12 refrigerant. I am taking the example of R12 refrigerant. There are two pressure lines, P1 and P2. We are assuming 0.06 bar. It is a pressure P. We are taking P1, and another pressure is, this is 1 bar. There are two pressure lines, which I already explained. First point number 1 is exists at dry saturated state. This is a critical point. From critical point, this is saturated liquid line, this is saturated vapor line. Here it is written as saturated liquid, here it is also written as saturated vapor line. Point number 1 is dry saturated. So we started from point number 1. Point number 1, there is a compression from 1 to 2. There is a compression process, and compression is isentropic. So these lines are isentropic line. I already explained in my previous video. In this, there is an isentropic line. We are drawing an isentropic line through this. So these are isentropic line. So we have to draw from point number 1. This is point number 1. 1 to 2. There is an isentropic line. We have to follow. Sure. This is P2 line. This is P2 and this one is P1. From P1 pressure, P1 1 to 2. This is point number 1. This is point number 2. There is an isentropic process. This is isentropic line. Entropy is constant. 1 to 2 is compression process. After this, point number 2 to 3. Point number 2 to 3. There is at point number 3. There is saturated liquid. This is from we are following point number 2 to point number 3. I am using some little bit darker line for this process to easily explain you. So this is point number 1 to 2 isentropic line. After this 2 to 3, again this is 2 to 3. There is constant pressure heat removal process. This is point number 3. 4, there is an isoenthalpic process. 3 to 4, there is an isoenthalpic process. This is isoenthalpic. Enthalpy is constant. This is point number 4. This is number 4. 4 to 1, there is constant pressure heat absorption evaporator. This is point number 1. Now I will use different to explain you. This is point number 2. There is decrease in temperature. I already show you decreasing at point number 2. At this point number 2, temperature 70 degrees Celsius. After this, another line is 60 degrees Celsius. After this, there is 50 degrees Celsius. Again 40 degrees Celsius. That's mean this line, at this line the temperature is 40 degrees Celsius. 40 degrees Celsius. That's mean in superheated region, there is decrease in temperature in case of condenser. But in between saturated region, this is saturated region. In this saturated region, the temperature is constant. But if we are moving this line, moving subcooling, again there is temperature. Here, these vertical lines are showing that this is minus 30. This is 30, 20. This is 10 degrees Celsius. Yes, this is minus 10 degrees Celsius. These are the temperature line. That's mean if we are again decrease in temperature. This is subcooling. This is for explaining for better understanding. That's mean in case of condenser, superheated region, at superheated region there is decrease in temperature. At saturated region there is a constant temperature, but at again decrease in temperature in subcooling, region. For only these 3 states for condensation. After this 3 to 4, there is an isoenthalpic process. That's mean H3 is equal to H4, isoenthalpic process. At this point, enthalpy is constant for 3 and 4 point both. After this 3 to 4 there is an expansion, isoenthalpic process, enthalpy is constant. 2 to 3 there is a constant pressure. Again 4 to 1 there is constant pressure heat absorption. This is constant pressure heat absorption QA. Due to heat absorption, the liquid vapor state. The liquid is converted into a vapor. That liquid particles are continuously converted into a vapor state. That liquid particle is continuously converted into a vapor state. So continuously converted into vapor state. Point number 1 heated. Point number 2 is superheated. Point number 3 is liquid plus vapor as per our given diagram. This is saturated vapor. Point number 1 superheated. Point number 2 liquid. Point number 3 liquid plus vapor at point number 4. This is point number 1, dry saturated. This is point number 2, liquid plus vapor. This is point number 2, overheated resin. Point number 3, saturated liquid. Point plus vapor. This is Vapour Compression Refrigeration System pH chart, which is the most important. Thank you very much.
वतन वतन मेरे आबाद रहे तू, है वतन वतन मेरे आबाद रहे तू, मैं जहाँ रहूँ जहाँ मैं याद रहे तू, मैं जहाँ रहूँ जहाँ मैं याद रहे तू, है वतन मेरे वतन.
Subscribe to our